Hello everyone, I welcome you all for the video lecture on operating systems and virtualization. The unit to be discussed is process management. Under that, we are going to discuss the topic process scheduling and inter-process communication. Process scheduling, it handles removal of running process from CPU, selection of another process, essential part of the multi-programming operating system is the process scheduling. Let us empathize. So if we look at why process scheduling, users expect fast response time, multiple applications run simultaneously, smooth communication between processes needed, systems should avoid delays and conflicts. Process scheduling, let us define it. How to schedule process efficiently, how to ensure fairness and responsiveness, how can process communicate without conflict. Let's ideate process scheduling. Use scheduling algorithms. First come, first served, shortest job first, priority scheduling, round robin, introduce time sharing systems. The prototypes are ready queue, CPU scheduler, dispatcher, context switching. Multi-programming and scheduling. Multiple processes are loaded into memory at the same time. CPU is shared using time multiplexing. It improves CPU utilization and system efficiency. Scheduling queues refer to queues of processes or devices. The types of scheduling queues are job queue, ready queue, and device queue. So this is how the diagrammatic representation looks. Job queue. It contains all processes in the system. It is maintained by the operating system. Processes wait here before entering into the memory. Ready queue contains processes residing in main memory, ready and waiting for execution. Every new process is initially placed here. Device queue contains processes blocked due to unavailability of input or output devices. Each device has its own queue. Queue representation. The rectangle represents queues. Circle represents resources. And then we have arrows which show the process flow in the system. Process execution flow. New process enters ready queue. It waits until selected for execution. Once assigned CPU, process starts execution. While executing, a process may request input or output resource. It is moved to the input or output queue. Create a child process and it waits for termination, and it is interrupted, moved back to the ready queue. Process cycling involves waiting, ready, running, and the cycle continues. Process repeats cycle until termination. On termination, removed from all queues, PCP and resources are deallocated. There are two-state process model. Process has only two states, running, not running. Schedulers. Schedulers are system software that manage scheduling. The main functions involves selecting jobs for execution, deciding which process to get run. Types of schedulers. Long-term scheduler. It is also called job scheduler. It selects process from job pool. It loads process into memory. It controls degree of multi-programming, and it balances input-output bound and CPU bound jobs. Short-term scheduler. It is also called CPU scheduler. It selects process from ready queue, allocates CPU to one process, fastest among all schedulers, and it improves system performance. Medium-term scheduler. It is a part of swapping. It removes process from memory, reduces degree of multiprogramming. It handles suspended processes. Process may be suspended due to input-output request. Suspended process makes no progress. Process is moved to the secondary storage, known as swapped out or rolled out. It's a comparison of the long-term, short-term, and the medium-term. The long-term is low, whereas short-term is moderate. The degree of multiprogramming, long-term, it converts minimal, it is minimal control, whereas medium-term, it reduces it. Two major operating system operations are process creation and process termination. Process creation is created using fork system call. Parent process creates child classes, and child is a duplicate of parent. Each process has process ID and parent process ID. Process termination. Process terminates after last instruction. Resources return to the system. Reasons for process termination or error exit. That is a fatal error. File not found. Example. Fatal error, illegal instruction divided by 0, or when it is killed by another process. Inter-process communication. Inter-process communication allows process to communicate with synchronized actions that is used to concurrent execution. IPC message system. It process communicate without shared variables. Two basic operations: send, message, and receive message. Communication requirements. IPC allows process to establish a communication link, exchange messages via send or receive, link implementation using physical and logical. Message passing system. Messages may be fixed size. Exchange messages via easy to implement. Several logical communication methods. Direct communication. Process explicitly name each other, send message and receive message. The send message contains the destination, namely P, then message, then in the receiver side, from the receiver name and then the message. Indirect communication. Indirect communication via mailboxes. Each mailbox has unique ID. Process share mailbox to communicate. Symmetric communication. It has sender and receiver name each other. Send P, message, receive Q, message. Asymmetric communication. Sender names recipient, receiver name sender. Example, receive ID message. Automatic buffering. Queue length is unlimited. Sender never blocks. Explicit buffering. Buffer size is fixed. Sender may block if buffer is full. Synchronous communication. Synchronous communication involves sender and receiver wait for other. One blocks until the other is ready. Asynchronous communication. Messages are buffered. Sender and receiver do not wait. So this is the mind map. This is coming to the end of the session. Let's discuss another video in the upcoming lectures. Thank you.